is going to be in the form y equals ab to the x, just like we talked about yesterday. And remember the rules here. A cannot be 0, because if it was, then the whole thing would be 0. B has to be positive. So if this notation here, b is greater than 0, just means it's positive. So you're never going to have a negative number that you're taking to the power for any of these questions. And b cannot be 1, because if b was 1, like in that position, 1 to any power is 1. And so again, if we plugged in 1 for b, it would be a line. It can be negative, it could be, or it can't be negative. It can be smaller than 1, but it can't be equal to 1. So here's what we are going to graph. Now, typically, if you guys saw this equation, they would not write it in the format that I just wrote it. They would write it as just y equals 2 to the x. I put the 1 in front of it just to let you know that there is an a value here. So for this question, the a value is 1 and the b value is 2. Now, I just literally made a table. So I'm going to show you, if you guys have a graphing calculator, I'm just going to show you real quick how to cheat and do this really quickly on a graphing calculator, or you can do this by hand. But if you type, and you might already have something in here, so we might have to change it. I'm just going to hit the y equals button. It's in the very upper left corner. Hit y equals, and if you have something in there, you might clear it out. And I'm just going to type, you don't need to type the 1. I'm just going to type 2 to the x. So I'm literally typing the number 2. I'm going to use the little caret key, and then let me scooch this up a little bit. You have to use the x button that is next to the alpha key if you're using the graphing calculator. That's for a variable. So type that key, and then that should put your exponent to be an x. Okay, now, do you guys know how to get to the table? That's okay, that's cool. All right, I use this all the time. All right, so once you type the equation in, you're just going to hit second, and then it's the graph button in the upper right. See how it says table right there? Just hit that, and that will give you a table. And we can go like up and down to get numbers here and stuff like that if we want to go through and do that, just to kind of speed the process up. Now, I'm going to just go ahead and I'm going to jot these down for this particular question. So it just starts at -4. And so I'm just copying these. You can actually plug, you could do like 2 to the -4 power. Plug that in by hand on your calculator. But if you want to save some time, using this table might make it a little bit faster. So I'm just copying these. And you'll notice some of these are kind of like icky decimals. What I'm going to do to the side, just if you're interested, I'm going to write down like 0.5 is 1 over 2. 0.25 is 1 over 2 squared, which is 1/4. This is 1 over 2 to the 3rd, which is 1/8. And this is 1 over 2 to the 4th, which is 1/16. So they're just powers of 2, just kind of going backwards. Okay, now I'm just going to come over to the graph and we're just going to plot a couple points here. So if it's a fraction, some of these are like really close to the x-axis. Just kind of do your best to kind of estimate. And then once you get to the y-axis, then they should actually be nice numbers, and then they get really big really quick. And this will give you a general shape. Okay, I want to add, this is going to get, on this side, this is just going to go up like super, like quickly. Do you guys see this question underneath here? Is this gonna go below the x-axis? Like, so it's getting like close here, right? I'm at like the smallest thing on my table there was 1/16. Is that gonna ever go over the x-axis? Does anybody know why it doesn't go over the x-axis? Okay, if you're actually doing these problems, like this guy is 2 to the negative 4th, right? If we kept going like to the left here, if I did 2 to the negative 5th, that's 1 over 2 to the 5th, right? If I do 2 to the negative 6, that's 1 over 2 to the 6th. Like the numbers, but the negative exponent never becomes a negative number. It just becomes a tinier and tinier and tinier fraction. So this does not actually touch or go over the x-axis. And I'm going to write down here, just know, if you have a negative exponent, like we're plugging in negative values for x, that's a fraction. And it's not going to be a negative number. Right? They're just going to be teenier and teenier and teenier fractions. Like I had 1/4, 1/8, 1/16. The next one would be 1 over 32. Then it'd be 1 over 64. And then it would be 1 over 128. So the numbers would just keep getting really, really tiny, so it gets really close to the x-axis, but it actually doesn't touch it and it doesn't go over it. And we're going to talk about this in 1 second. So the x-axis here, I'm just going to kind of highlight. That's going to get where my graph is going to get really close. The actual equation of the x-axis, and I know this is super weird, but the actual equation of the x-axis is y equals 0, because all the y coordinates are 0 across the x-axis. When you're a horizontal line, it's y equals that number. I call it horizontal to remember, but literally every y coordinate across that line is 0. The x coordinates change as you go left and right, but that's y equals 0. And I'm just going to draw a little tiny arrow. We'll talk about this in 1 second, but that's going to be what we call an asymptote. Before we get to that, though, I want to do the domain and range. So what would you guys tell me, like moving left to right? This is just a general exponential growth, right? Because my b value is bigger than 1. Would you tell me the domain is for this? Like left and right. Okay. Yes, this goes left forever, this goes right forever, negative infinity to infinity. Okay, now, the range, when you do this, you're going to come from the bottom of the graph, right? You don't touch any part of the graph, and you don't touch 0, because remember I told you it's just going to get, those fractions get super, super small. They get really close to that, but they don't actually touch it. They don't go over it. So you don't actually touch 0. So when you do the range, I'm actually going to use a parenthesis here, because I don't actually touch 0, but it's going to get really close to 0. And then the rest of the graph is pointed up forever. So there's nothing below there. I don't even have a graph for that below there. So it's going to be from 0 to infinity for your range. Does anybody have a question so far? This is not terrible to do, I promise. Okay, now, an asymptote is that line I just kind of highlighted on my paper. It's a line the graph approaches, so it gets close to it. All these graphs have an asymptote, but they're not going to touch it. They're not going to go over it. All right, and now I'm going to draw you a little picture for each situation that we're going to graph today. We just graphed growth. So if you have exponential growth, the general shape for that is going to start small and then it gets really big really quick. It's kind of like a J shape. If you have decay, that's actually going to kind of start bigger and then get really small really fast. So then that goes down, kind of like a backwards J shape. In both of those situations, growth or decay, the A value is positive. If you have exponential growth, your A value is positive and your B value is greater than 1. If you have exponential decay, your A value is positive, but that's the one where the B value is between 0 and 1. So like a half or something like that, that's going to cause you to have decay. Now, if you're in the situation where they call this neither, this is still exponential, but it's not considered growth or decay. That happens if A is a negative number. And if A is a negative number, it's just going to take those two shapes and flip them down, but there's actually two. So if your exponential points down, that's going to be not exponential growth or decay. Exponential growth and decay both have to point up. If you have neither, and it can go either direction, like flipped, basically those two flipped over. Sorry, these are supposed to be like two separate graphs. They're not together. but can go, if it goes down, it's not exponential growth or decay, it's in the category of neither. If it goes up from left to right, it's growth. If it goes down from left to right, then it's going to be decay. And we're going to graph all these to practice today. Does anybody have a question? Okay. Now, all the asymptotes are actually going to be the same today. So we're not shifting anything. This is 36 times 1/2 to the x. So would you guys tell me this is growth or decay? Okay, I was going to have a heart attack. I'm so quiet. All right, decay, right? So that's 1/2. That's between, if that b value is between 0 and 1. So I know the general shape of this should go like that. Okay, now, here's the deal. I'm going to make a little table here. And I'm going to kind of put 0 in the middle. All right, if I use an exponent of 0, like if I actually plug in 0, so I'd have, to get my y coordinate, I'd do 36 times 1/2 to the 0 power. Anything to the 0 power is what? 1. I know everybody forgets that. Anything to the 0 power is 1. So when you do that, my y value is going to be 36. So that's just, and just kind of estimate where this would be on the graph, okay? Just kind of estimate. So it would be at like, what is this? This goes by 10. So just like a little bit under the 40. That'd be 36. Okay, now the way this works is each time I'm going to cut everything in half. Basically, whatever your a value is going to be where it touches the y-axis, right? Because anytime if I have an exponent of 0, it's just going to wipe out that whatever to that power, and so we'll just have the a value. So this is going to be your y-intercept here. It's just 0 and then the a value from the equation. I'm going to put that kind of in the middle of my table. Okay, now, what am I going to do? Like if I plug in 1, what is that going to do to the 36? Cut it in half. Okay, and you can plug these into the calculator if you want to, but this is going to cut this in half. So each time I'm going to cut this in half. So then it would be at like 1/18, so I'm just going to kind of go close to the 20. And then if I keep going, you're just going to keep cutting it in half. So 18 cut in half would be 9. So then for 2, I'm going to be like just a little bit below the 10. Okay, what if I went the other direction? What if I went like -1? What would that do to the 36? So if I was at 36 and I went backwards, because I'm going to cut it in half every time, but if I'm going backwards, what would you do to 36 to go backwards? Double it, exactly. Okay, so this would be 72. And you guys can plug these into the calculator, you get the same numbers. I'm just showing this to you real quick. And then if you're going backwards, you're going to go by the reciprocal, just multiply it by 2. So every time I'm cutting these in half as I go backwards, or as I go forwards. So, and just kind of estimate where these would be. So like -1, 72, just like a little above the 70. -2, we're at 144, so like up here. And then this, just kind of make that curve. It's like a backwards J shape. But again, you're going to get really close to the x-axis, but you're not going to touch it. You're not going to go over it. So it should just be like that. Like if I kept my table going, if I kept cutting this in half, this would be 4.5. And then if I kept going, it would be 2.25. And they would just keep getting smaller, but they would never actually become 0. So you're going to have asymptote again here for all these questions today. This is going to be the x-axis, which is just y equals 0. So my equation for my asymptote, I'm going to write y equals 0. Now, domain still goes left and right forever. There's no restriction on what I can plug in for x in that equation. I can plug in negative numbers, positive numbers, whatever. The range, though, never goes below this x-axis. Okay, so I don't get any y values underneath here, and we got to start this with a parenthesis because we don't actually touch the 0. And I know the graph goes up to the left, but it's going up. So 0 to infinity is going to be your range. Is anybody having a question? Okay. Now I'm just going to kind of do like one of each type. Easiest thing I can do to tell you to make a table. It's going to tell you to make like 5 points. All right, this guy's going to be decay because I've got a 1/2 as my lovely B value. So I'm just going to put 0 in the middle. If you plug in 0, if you actually plug in 0, so you do 1/2 to the 0 power, that would be 1. The Y value should just be A, so 0, 4. You can use if you guys prefer, you can totally use the table. Like if you want to grab your graphing calculator, I'm going to just type in, do like 4 times, I'll just do 0.5 to the X. You could do that too, and then hit second graph and look at your table. Or you can make the table. It's completely up to you. On this question, if I would go to the right, I would cut it in half. So like I know the next point would be 2. If I plug in 2, that next one, we're just cutting it in half. So it would just keep going in half. If you're going backwards to graph a couple negative X values, instead of cutting it in half, I would go backwards, so I would double it. So like this would be 8, this would be 16. And then you guys can plug just kind of, these are not the greatest graphs I've ever created, so just kind of estimate. It's just going to ask you to graph at least 5 points. And it should make kind of that general shape that we had on the front. It's going to get really close to the x-axis, but it's not going to touch it, and it's not going to go over it. So just make sure you don't draw it over the x-axis. The asymptote should just be the x-axis. And so I'm going to write y equals 0. All these actually today that are growth or decay should have the same domain and range. If they're in the neither situation, then hang on, let me zoom out. I can't even see everything I'm writing here. Okay. So, should be negative infinity to infinity, goes left and right forever. Don't start the graph till you hop over 0, and then you're up. Okay. Now, this guy, again, if you want to use the table on your graphing calculator, please feel free. You just got to graph 5 points. What I would do here, though, I'm just gonna put 0 in the middle of my table. If I plug in 0, and I've got y equals 3 times 2 to the x. If I plug in 0, what would my y value be? 3. All right. Now, so 0, 3. Now, if I go forward, if I go to the right, like if I start increasing these values, what you're doing every time is you're going to double it. So 3 double 3 would be 6. If I double 6, that would be 12. Now, if you go backwards to get some negative coordinates, to get a better feel for the graph, you would divide by 2 going the other way. So this would be, if you have negative 1, be 1.5. If I cut that in half, that would be 0.75. And if you guys want, like I'll just show you real quick on the table, just going to do y equals, what is this, 3 times 2 to the x. I usually just put parentheses around whatever number we're taken to the x power just to make sure the calculator will do it right. And then I'm just going to show you my table here so you can see they're the same. So like the negative 2 is the 0.75, negative 1 is 1.5. But it might be faster for you to just kind of do it by hand. It's completely up to you. And just if you're going to graph this, we're just going to plot these points. Just do it the best you can. It doesn't have to be perfect. Some of the points are nice, and some of the points just do your best to estimate. So like negative 1, 1.5, I'm just going to try my best to go between the 1 and the 2. Negative 2.75, kind of close to the negative 1, but a little bit below it. And this should make that kind of that J shape. Asymptote for every single question today should be y equals 0. We're not shifting anything. We'll do that tomorrow. And then if you have growth or decay, this guy's growth, the domain negative infinity to infinity. And the range here, you don't start touching the graph till you hop over that asymptote, so it'll just be 0 and then it goes up forever. We're just using parentheses whenever we have an asymptote because you don't actually touch the asymptote. Okay, is anybody having a question? All right, we're going to finish these up real quick. Now, these 2 at the bottom, if you guys look at the 2 at the top, literally all I did was I changed the A value to be negative. That's literally all I did. So what is that going to do if I change the A value? I'm just going to write the same little table here. If I change the A value to be negative, what would that do to your Y values? if I just put a -4, it's identical to this question at the top. I just made it -4. Why am I sliding this all over the place? Okay, this is 4. Everything else is the same. This is just -4. What would that do to the y values? It's literally it. They're going to be the same numbers. They're just going to be negative. So I'm literally just copying the table. Like this would be -16, -8, -4. Your a value should be 0, whatever your a value is. That should be your y-intercept. And then we would have -2, -1. Now, this is what it's going to do. It's going to take that graph we just did directly above this, and it's going to flip it over the x-axis. So this is going to get really close to the x-axis again, but it's not going to touch it, not going to go over it. It's going to point down. So if we're at like -2, -16, that's a nice point. -1, -8, that's a nice point. 0, -4, 1, -2, 2, -1. This is just taken and flipping that graph directly above it over the x-axis. So the asymptote is still the same. This is in the situation where we would consider this neither. This is not growth, this is not decay. If it's pointed down, it's neither one. This is a situation where my a value is negative. So that would be the shape just in general. The asymptote is still y equals 0. The domain and range though, or the domain's going to be the same. It's still going to go left and right forever. It's just underneath the x-axis. The only thing that's different here is the range. So here, since this graph is pointed, I need to make these graphs smaller so I can get them on the screen. This graph is pointed down forever, so the lowest possible y value would actually be -infinity. And if you were tracing this from bottom to top, you would stop touching the graph when you get to that asymptote, so that range is just flipped over from what it is if you have exponential growth or decay. Now this one, the one right next to this, is a flipped over version of the one directly above. I changed it to -3 times 2 to the x. So I'm just going to use that same table, -2, -1, 0, 1, 2. The numbers are just going to be negative. So it'd be like -0.75, -1.5, -3, -6, -12. So this is going to be a flipped over version of what you have directly above it. So if you're graphing like the -0.75 and the -1.5, just do your best to estimate. But like 0, -3 is a nice point, 0, -6 is a nice point, and I just said 0, -6, sorry, 1, -6, and then 2, -12. That's a nice point too. And just make sure, don't draw it over the x-axis. It's just be a little curve. Get really close to it, never touch it, never go over it, because that's going to be an asymptote. We're going to get really close. But it would never, in this case, none of the values would ever become positive. So my asymptote here, y equals 0. Domain still goes left and right forever for all these graphs. Any exponential function, the domain should be -infinity to infinity. It'll go left and right forever. The range here, though, since this is pointed down, this is like the question right next to it. It's -infinity, and it stops at the asymptote. Is anybody having a question? It's not terrible to do. I think there's